This presentation is based on the paper A Jellyfish Distribution in Space and Time Predicts Leatherback Sea Turtle Hotspots in the Northwest Atlantic. It is by Bethany Nordstorm, Michael James and Boris Wem, presented by myself along with my colleague Anna Clark. This is an introduction and a brief overview of the study. Migratory movements often take place between predictable locations, such as breeding and feeding habitats, that meet different life history requirements. The study builds upon previous work demonstrating a seasonal correlation between the timing of annual jellyfish blooms in Canadian waters and the arrival of migrating leatherbacks. Figure 1 shows the study species and the area in Atlantic Canada. The study took place in Atlantic Canadian waters in three main areas: the Bay of Fundy, the Scotian Shelf, Gulf of St. Lawrence. The study combined 12-year datasets for jellyfish and leatherback distribution throughout the region with sea surface temperature data to explore whether changes in ocean climate may affect jellyfish distribution and leatherback foraging. The jellyfish data was obtained from the Canadian DFO, who perform annual scientific trawl surveys. Bycatch data was used to calculate distribution, biomass and abundance. Leatherback data was also obtained from the DFO and collaborators, who used satellite tagging to track 62 leatherback turtles. The sea surface temperature data was also provided by the DFO, who used remote satellite sensing.
So what were the findings of the study? Well, let's look at the first question. How do spatial hotspots of jellyfish and leatherbacks in Atlantic Canada compare? As seen in Figure 5, there is a hotspot of both jellyfish presence and leatherback turtle density around the Magdalen Islands, and this is due to the high upwelling of the region, causing high primary productivity, so phytoplankton become abundant, and this is the jellyfish food source. There is a cold spot of jellyfish presence and biomass, as well as leatherback turtle density in the Bay of Fundy, and this is because there is an inadequate prey source for the leatherback turtles. The Scotian Shelf is neither a hot spot nor a cold spot because the leatherbacks move through this region to other foraging areas. Now let's look at the second question. Are jellyfish ranges expanding or shifting over time? Figure 6 shows that from 2006 to 2017 there was a northward shift seen in both jellyfish occurrence and weight. Finally, let's look at the third question. Are there any changes in jellyfish abundance and distribution driven by changes in sea surface temperature? Figure 7 shows that there was a sea surface temperature increase in all three regions of Atlantic Canada, and this led to an increase in both jellyfish presence and biomass. Increased temperatures benefit jellyfish by increasing their growth rates and speeding up maturity. These findings indicate that climate change could have an impact on jellyfish and leatherback distribution. Their seasonal foraging ground should be a high conservation priority, and the protection of this critical habitat should include dynamic approaches to management. There were of course limitations to this study, and further research will be required to monitor and predict the distributions of jellyfish and leatherbacks so that we can manage conservation effectively in the future. Thank you for watching.